Welcome to this explainer. Today, we're diving into something that literally sounds like it was pulled straight out of a science fiction novel. We're going to explore a truly fascinating experiment where a suite of artificial intelligence models attempted to reconstruct the fundamental laws of physics from the ground up. By completely stripping away our traditional, deeply held scientific assumptions, these AI models did something pretty remarkable. They wrote a brand new framework, one where the very fabric of reality, space-time itself, is not at all what we thought it was. So let's dive in and uncover how AI might have just rewritten reality.
Right, so for over a century, physics has treated space-time as this smooth, continuous stage. It's been the unquestioned background of our reality. Matter moves on it, light travels through it, quantum fields vibrate within it. It's always just been a given. But the ACS framework makes a radically different, almost heretical proposal. It suggests that space-time isn't fundamental at all. Instead, it's an emergent illusion born out of microscopic causal networks.
So we have to ask the profoundly uncomfortable question that these AI models shoved right in front of us. What if treating space-time as the fundamental stage is completely backwards? What if the stage itself is actually built out of the interactions of the actors?
Enter the ACS framework. In this mathematical model created by the machines, reality doesn't consist of points in physical space. There's no background manifold. There is no existing continuous fabric. At the most fundamental level, distances literally do not exist. Instead, there are simply events that happen before other events and after other events. It's pure cause and effect. Space-time geometry, the distances, the dimensions, the shapes we experience every day, only emerges later when those causal relationships become highly persistent and start to look geometric.
Think of it like a massive, evolving web of information. If you run that causal network forward with one incredibly simple, almost recursive rule, which is just that things that persist, persist, something absolutely incredible happens. The very geometry of our universe literally begins to build itself.
And as this geometry builds out, three distinct, massive pillars of modern physics naturally fall right out of this network without being mathematically forced. Gravity, quantum mechanics, and a highly specific cosmological fingerprint all emerge naturally. The AI didn't have to arbitrarily program these in, they're just inevitable consequences of the network's geometry.
Okay, first up, gravity. In standard physics, gravity is a postulated force, right? It's something we have to manually inject into the equations to make the universe work. But here, we don't have to invent gravity at all. It appears by simply counting causal intervals within the network. The AI's math shows that a specific calculation appears naturally through this counting process. And Einstein's famous equations? They perfectly describe the large-scale limit of that exact counting. Gravity is just the geometry of cause and effect written large.
Second, we get quantum mechanics. Traditionally, physicists rely on the concept of wave function collapse, which, let's be honest, has always been a massive conceptual headache. But in the ACS framework, you can toss that out. No wave function collapse postulate is needed. Quantum probabilities actually appear because the network essentially measures itself through its own structural symmetries. There's a specific pattern called a C6 motif, which is simply 6 causal events connecting in a loop, and that creates a natural unit of persistence. That little loop is natively where quantum probabilities come from.
Now, this framework also completely flips the script on one of the most famous mysteries in science, the hierarchy problem. In standard physics, scientists lose sleep over why gravity is 10 to the 32nd power times weaker than the other fundamental forces. It is a massive gap that usually requires inventing mysterious, hypothetical particles just to make the math work out. But in the ACS framework, that weakness isn't a mystery to be solved. It's encoded directly into the causal network itself.
Just look at this staggering number, 8 times 10 to the 232nd power. This represents the ratio of two specific values in the AI's data. This isn't fine-tuning or some manual adjustment by a scientist tweaking a dial. It's the exact scale where causal persistence transforms into the geometric reality we actually experience. Gravity is overwhelmingly weak because it's a macroscopic averaging of this unfathomably huge number of microscopic causal events.
So what's the crucial takeaway here? It's that quantum mechanics and gravity were never separate forces to begin with. They don't need to be awkwardly stitched together. They are simply two descriptions of the exact same underlying mechanism, how information persists in a causal network. And this elegant unification brings us to the final, and honestly most exciting, observable pillar of the ACS framework.
Because the AI's code didn't just build some abstract math, it generated a very specific physical prediction, the cosmological fingerprint.
Unlike standard cosmology, where scientists have to fit free parameters to match the background radiation of the universe, the ACS framework physically predicts a specific fingerprint at a massive scale of 100 megaparsecs.
By analyzing what physicists call the heat kernel of the persistence tensor, I know, that sounds super dense, but stick with me, the AI's framework generates a precise correction to the inverse square law at cosmological scales. This produces a highly specific spectral index prediction, known as NF. And importantly, this prediction is purely derived. It is not tuned. The AI didn't peek at our astronomical data to make its math work. The math autonomously forced the prediction. That completely unforced mathematical framework spits out this incredibly specific, measurable number for the large-scale structure of the universe, 2.021.
And this is where things get incredibly exciting. When we compare the AI's derived prediction of 2.021, which has a tiny uncertainty of plus or minus 0.005, to the current best real-world data from the ACT telescope, which sits at 2.1, we see something amazing. With the ACT's uncertainty margin of plus or minus 0.3, the AC's prediction of 2.021 is actually inside the error bar. Barely, but it's in there. It's setting up a massive scientific showdown between standard cosmological models and this new AI-derived causal network.
And we won't have to wait long for the results. Future astronomical surveys like Euclid, DESI, and the next cosmic microwave background releases are going to test this exact number with unprecedented accuracy. The absolute beauty of the ACS framework is that it makes a specific, falsifiable claim. If these upcoming high-precision surveys pin that data strictly to 220, the ACS framework doesn't need to be tweaked or adjusted. It will simply be dead wrong.
As the source text brilliantly puts it, that's not a theory of everything. That's a theory that can be killed. In theoretical physics, having a model that openly invites its own destruction by pointing to a highly specific, checkable number in the sky, that is astonishingly rare. It's a real testament to the deep scientific rigor of what these AI models have produced. The derivation is public, the code is public, and the prediction is just waiting to survive contact with the data.
So the core takeaway here is a fundamental shift in how we view our very existence. If this framework holds true, reality is discrete at the microscopic scale, sure, but it's discrete in causality, not in space. The continuous, smooth fabric of space that we navigate every single day is essentially just an approximation. It's the macroscopic illusion of underlying cause and effect happening on a scale we can't even fathom. Which leaves us with this final, perspective-shifting question to ponder. If a machine mathematically proved that space-time itself doesn't fundamentally exist, how are you going to view the vast, empty space between you and the stars tonight?